So, Cesar, welcome to the Mr. Beacon podcast. It's great to have you.
Oh, thank you very much, Steve. It's a pleasure to be here talking to you.
Well, it's kind of weird. We're both we're both in Las Vegas, so I'm just going to turn my. So this is the view from my room, and
Nice.
but unfortunately, I left my recording gear behind. Otherwise, you and I would be sitting in the same room, and it would be a little bit more human. But we're back to COVID style interviews, and so anyway, I'm glad we saw each other, and I've been wanting to get you on the show forever. So thanks for joining. You run a really interesting company, CEO of Energous. So I want to talk about what Energous does and broadly. I do want to talk in particular about the ESL market that you focus on. And then, of course, you and I know each other because Energous is a works with Wiliot partner. And so we have that in common. I kind of want to get your perspective on where we are and what you do in that context as well. So we've got a lot to talk about. Maybe we should kick it off, and you can just introduce Energous, the company, and explain a bit about what the company does.
So definitely, Energous is a fabless semiconductor company focused in the development of technologies that are specific to wireless power networks. And when I say wireless power networks, I'm talking about a radio frequency-based energy transmission that allows you to send and transmit power from transmitters into receivers. From that perspective, we are the company that wants to remove batteries and the company that wants to remove wires. We see a world where we can deploy our technology very similar like we deploy Wi-Fi or other communication technologies and energize rooms. And once you energize the rooms, you can have any type of receiver that basically can work within the operating limits of the power that we provide.
I mean, it's a compelling vision. Obviously, there's a lot of commonality with Wiliot, the company where my day job is, and we'll get to that later. But this what you're doing is actually quite different to what Wiliot does. We're not thinking. I mean, you're like charging significant appliances. We're driving these postage stamp sized sensors. What sort of what is the scope of what is possible with this? What I would describe as power transfer, radio power transfer technology. What kind of devices can you power?
So that's a very good question, and it can be answered in two ways. So let me answer it from a technology point of view first. From a technology point of view, there's no limit on the amount of power that you can send out. You can send watts of power, kilowatts of power, and get into very, very long distances and able to actually charge large devices, right? But within the constraints of regulations, that might not be actually allowed, right? And you'll have
Hmm.
to have a certain level of power that effectively, if you want to have humans in the room, you have to constrain that power. So from that constrained power regulation, what happens is, and the reason we exist as a company, is that when we started the company, the regulations did not allow us to send effectively power over the air. All the power that's really sent over the air is constrained to communication networks, to pretty much 1 watt conducted power with lots of limitations and overhead, and no basically 100% or high capacity or high duration duty cycles, right? So so going back to what we do in the company is we build now devices that send the power that are within the certification parameters that we had to actually push forward because remember half a millimeter, and today we're very happy to have no limitations on distance, specifically with our 1 watt power bridge, which is one of the main components that we actually interface to the Wiliot tags.
Hmm.
And recently, as of a couple of weeks ago, we were able to actually get our certification from the FCC, where we can actually send 15 times more power than we did before, all the way up to 15-watt conducted power. Okay?
And did something change that's allowed you to break through that 1 watt ceiling? What
Definitely.
was?
So what we did in the company, besides all the patents that we put together in this technology, is that we are experts not just in the technology and being able to build the systems and understanding the certification process or not, but we also know what the human body can actually uh, take as far as the amount of energy that is present without causing any damage, right?
Hmm.
And we were able to identify and mix knowledge that we had on the phone world, with the communication world, and come up with a set of parameters that we discussed with the FCC and ended up on a KDB. But just to summarize this, there's a specific absorption rate level that the human body cannot exceed, which in the US is about 1.6 watts per kilogram of mass. Okay,
Hmm.
so as long as you don't exceed that, you don't expose people to that level of power, you'll be safe. In fact, your phones are around 1.3, 1.4.
Hmm.
So, but the great thing, and at the same time, the bad thing about RF is that the closer you are to the transmitter, the closer you are to the energy level. But the
Hmm.
further you are from the transmitter, because RF actually goes down logarithmic in a logarithmic way, right?
Yes.
I mean, it goes down in proportion to the square of the distance. The level of power that you end up having when you're sitting on a desk, assuming that your transmitter is on the top, is really negligible. So that effectively helps us to deploy this technology in a safe manner and having humans. So as long as the human, for instance, in our uh, 10-watt transmitter is within 20 centimeters of that transmitter, there's no damage
Hmm.
based on the measurements and the way that we have actually built our transmitters and our antennas, things like that. So
So,
if you
so do you turn down the gain when
no,
if someone's nearby, or how do you?
no, it's
Okay.
all today. It's all on all the time. So our
Hmm.
15 watt is basically uh, approved to be on all the time without the distance limitations. But what your question says is something interesting, that if we can do 15 watts with humans inside the room, go imagine when they go to sleep and they just premises are empty, and we can just jack it up to any level and then charge things even faster.
Right.
So, so
Right.
that's another option that we have not explored with the transmitters that we have today with Wiliot. But you could potentially do that. You could deploy, let's say, a 15-watt system today, no distance limitation in the US, and then at night you can jack it up to whatever you need. Now, you might complain to me and say, well, that's going to be expensive. Yes, it gets expensive because you have to build now bigger transmitters. But if the company that you're dealing with is willing to pay the cost of that, then sure, it makes sense.
So what kind of devices can you power in a practical way using the technology that passes those FCC
Sure.
regulations?
So our focus right now is being Internet of Things, devices that are in the milliwatt level, I mean,
Hmm.
1 milliwatt, 2 milliwatts or so. But when we talk about power, we have to be careful. When we talk about energy, we have to be careful because you and I probably understand better than most people what I'm talking about. But reality is that we've all been educated to use batteries. And the world of batteries, you charge the battery as fast as you can and you use the battery as much as you can.
Hmm.
And you and I now live in a different world, which is you just send enough power to turn on the device whenever you need the device. And if you don't
Hmm.
need it, you just save that power, right? So the world has
Hmm.
changed. So now milliwatts might not sound like a lot of power, but the reality is that it is plenty of power to even power basically wearables. Okay, so I would say all the way up from microwatts of power to devices that could be wearables level 100 milliamps or so that could actually charge at 3 milliwatts, and that would be plenty to actually be charged within a 24-hour period as long as you're on the energized room.
Okay. So IoT devices is the focus, and in the case of Wiliot's tags, yeah, we have a little capacitor and we accumulate the energy gradually. It's like a little bucket filling up with a stream of water, and then we have enough energy, and the bucket flips over, and suddenly you have, you've got enough to do some interesting things. So we'll get to Wiliot in a bit, but I want to talk about electronic shelf labels. How that seems to be one of the applications that is really getting traction. I was over in Italy on holiday with my wife and son, and I went into all these stores, and they all had ESLs, electronic
Mhm.
shelf labels, everywhere. And what do you see happening in that market, and what's your role in that market?
So as a company, as of a year ago, we have focused on three markets, and we announced our third market about a month and a half ago. Our goal is to focus first on RF tags, which is what we do with Wiliot,
Mhm.
ESL, as you pointed out, and then sensors. And when we come to sensors, temperature sensors, humidity sensors, CO2, air quality sensors, motion sensors, and so on, right? So in the case of ESL, you're correct. I was in Europe too recently. I was in France and Germany, and everywhere you walk in there, you'll see hundreds and hundreds of these tags and prices everywhere. The same thing is going on in Asia. The reality is that this is moving faster in Europe than it's moving in the US. As simple as that. So ESL and being able to display and being able to automate the information that you provide to consumers and to potential customers is something that's happening, right?
Why is it happening? What is it that what's wrong with good old fashioned printed labels stuck on a little holder on the shelf?
It's the same problem that you have with little labels that have little papers instead of Wiliot tags. And the number of little tags that you have to put together is so large, and the overhead that you have is so uh, I guess, large, and the time that it takes is just not effective. And the number of mistakes that people make is also pretty high. So by automating and having real time dynamic, a dynamic process can be developed by which things are more, I guess, up to date,
Yeah,
and mistakes will not be made. And of course, if you want to make now that store dynamic, you can change that tag as the customer moves around. You move around and it was Steve. Steve likes this, give him 10% and you'll get that 10%, right? So
you
the
can
work's
have happy hours, discounts, but also you get more information, right? You don't you
that's
you
correct.
can. It's not just the price; it's actually information that helps you buy, and that's what merchants are in the business of doing, having all the infrastructure to sell more stuff. So it makes sense. So we're seeing. And I hear that America is going to be catching up. It seems like the major retailers are committing to ESLs over here, and a bit like the credit cards. Over in Europe they were all tapping for years, and now we're doing it. But we're such a big country; it just takes time for infrastructure renovations to happen. Even though we think of ourselves as being very progressive.
Yeah, that is true, but it could be also related to tax, uh, what is it, taxation, right? I mean, I remember when I worked in the Bell system, if you deploy a new network, it would take 10 years to depreciate. So people here in the US, they just wait for the depreciation and then they'll update. I know other countries in Europe and maybe in Asia, they have a different taxation form that allows them to move faster. So that my guess is it's probably something related to that.
Right. Yeah, very interesting. Okay, so ESLs, we can expect a lot of them, and how are they? What does that market look like? Where are you
Sure.
positioned?
Sure. You're talking about a TAM of about $76 billion or so. But I think from our perspective, which is a fundamental thing of our company, is that it always feels good to remove batteries for sustainability purposes. And by removing RF tag batteries, I mean, you have thousands of those, but as you said, there are also thousands of those ESL tags everywhere. So being able to remove those batteries and being able to actually make a network that shares the same infrastructure with different components, whether they're sensors, ESL, and so, it's pretty interesting to us. So if you look at the market itself, we're probably talking about over $280 billion of total addressable market that we'll be touching with all the components that we're putting together. And certainly some of those markets will have vertical markets that we need to go and optimize and be able to get partners to help us deploy. But it's a large market just in those four markets with those three applications that I've talked about.
And so your devices, they can provide the power that these ESLs need. And I mean, my observation is a lot of them are these e-ink type things where they're not like, it's not like you're having to burn a cathode ray tube that's displaying this thing. It's just enough power to change
That's right. So the world is changing. Basically, what you're saying is the world is changing, right? And the world is changing because devices have to be lower power. And the way you actually save energy, because we've been wasteful of energy as humans, is to actually design components that do not burn power. So in the case of e-ink and those displays that we have in some of our ESL displays, they're just basically burn power when they change the image. Otherwise,
yeah.
they just sit there and don't do much. And the world is, again, is going to continue to low. I mean, your techs are very low power. I expect ESL devices to go low power, BLE to go even more low power, Wi-Fi to go low power, and pretty much everything is going to converge at some point in time. As there's more functionality, power goes down, and then we deploy more of these networks.
And so the role of that Energous device, which actually I should have, I don't know if you have one around. Maybe I do. See if they're pretty small. Here we are. There we are. Never travel without it. So,
I'm sure you
uh,
plug it in your room there and power your Wiliot tags.
exactly. Yeah. But that can be powering the ESLs, or something like that can be powering the
So yeah,
ESLs.
so our view, we have a much broader view. I mean, we're looking at RF power or the transfer of RF or of active harvesting energy as an exercise of the deployment of those power bridges, very similar to Wi-Fi, where you deploy those as needed, maybe every 10 meters or 15 meters. And as you do that, you effectively now have energized the room. And energy is common to all sorts of components, as we pointed out, all the way up to wearables, right? So anything that's in that area where you, let's say, deploy the Wiliot tags, will also be able to be energized with the same transmitters that you have for ESL and then sensors and so on. So what we're effectively doing is we are supporting the deployment of the next generation energy transmission system. And as in the case of Wi-Fi, where we ended up deploying large numbers of transmitters, and people don't realize today because they just like to use it. But the history is the same. There will be an evolution. You start deploying those, and over time they'll be so predominant that anywhere you go, I mean, you'll have power on the go, the same way you have communications on the go. So that's how we looked at it. It's independent of the receivers. Now, once you have that infrastructure, will your tags work flawlessly and transparently? ESLs will work, sensors will work, and we're looking at other vertical markets where effectively those receivers will also benefit from it. So now you build a world that is really batteryless in a way.
That's great. So you're building an infrastructure, you want a next generation store, you want dynamic pricing, the ability to provide more information, sales information to your electronic shelf labels, but you also want real time continuous inventory. You know exactly what's on the shelves. If something's been put in the wrong place, you can do that with Wiliot tags. So that's probably a good segue into what you're doing with Wiliot. Would you like to kind of describe a bit? I guess either of us could do this, but you're the guest, so I'll let you talk a bit about what you're doing with Wiliot.
Yeah, and feel free to add because you are the
Mhm.
mastermind at Wiliot, and you know.
I'm not sure whether that's true, but I am definitely the talking head. I do more
Okay,
talking about it
okay.
than most people, maybe.
So we, we have a partnership with Wiliot, and certainly there is a way to harvest power from the air, but when it comes to deploying labels, in our opinion, that need to be time critical, that need to be there with a certain uh, priority, and also when it comes to being able to have the right range to be able to have high coverage. I think that's where Energous and Wiliot worked really well together because
Mhm.
our technology runs at 900 megahertz, and while some of your tags are dual band and they operate at 2.4, you can easily extend the range of the devices by 3 to 4 times.
Mhm.
And by adjusting the duty cycle of the power that we send, you can basically play and decide how fast or how slow you want to charge those devices and so on. right? So now what we do with you is we effectively deploy what we call today an intelligent wireless power network, or also known by us as active harvesting, as opposed to the fact that we have passive harvesting, where you try to get power from your Wi-Fi devices and your BLE devices, right? But it's still with Energous, what you get on top of that is that when you're working at 2.5 gigahertz today, you're working with communication networks that are really capped to 1 watt. And by using Energy technology, you have 1 watt transmitters that will give you that range, that will give you more duty cycle than what you can get. But now with our latest 15-watt system, you'll actually get 15 more times more power than you did before. So you'll have more range, or you'll be able to actually have better coverage or penetration and so on. So that's basically how we see each other. And certainly there's also the communication channel by which we provide the BLE back channel to control all the receivers and gather the information, concentrate the information, and then provide that to your cloud. So it's a
Yeah.
perfect partnership. We add value to each other. Yes.
Yeah, so the way I see the Energous power bridge devices, we call them a bridge, and it's like a stepping stone between the gateway. The gateway could be a Wi-Fi access point that's going from the world of Bluetooth to the world of Wi-Fi and out to the wide area network. We see like a store where for really a very modest amount of money, you can blanket the entire store with a predictable source of energy. And also, your devices are transmitting Bluetooth to supplement the sub-gig. They're calibrating our tags. They're also reading the tags and relaying selectively the interesting information and actually boosting that signal. So you may read a weak signal from a Wiliot tag, and then you'll relay that and boost it at a much with a much stronger signal that could go 50 meters to a Wi-Fi access point that's
That's correct.
out of line of sight. But I think what those stepping stones, your devices do, is they also provide points of location. So, we can put one of your bridges in the back room, one in the front display, one in the changing room, one in the different parts of the store. And
Right.
suddenly we're establishing zones in the store where your very cost-effective devices are providing energy, but they're also telling us, oh, that skirt that has been tagged has been moved to the back room. It's now on the shelf. It's moved from the shelf. It's now into the changing room. So if someone goes online and they say, oh, that's the garment I want to buy, the staff aren't running around trying to find where that thing is because of the zones that the Energous bridges have.
Right. And,
have
and I think that's also the beauty of your labels, right? Because
Yes,
what you have is you have labels that are energized constantly, that take
yes,
advantage of that fact, as opposed to, let's say, RFID, right? They're
yeah,
always there, and because they're always there, the latency is pretty low. And as you move around, you effectively know, as you pointed out, where things are. And in the case of other technologies, you just cannot do that. So you guys have added now smarts and call it instantaneous responses to labels that did not exist before. And with our bridges, we definitely can keep up on that. And as you said, point the location, control the output power of the transmitters if needed, right? And constrain the areas and build, if you want to call it, a microcell of energy and data that allows us to find thousands and thousands, and as you guys always say, effectively trillions of these devices. Yes.
yes. I mean, so you're a member of our partner program that works with Wiliot program. We obviously work with many different manufacturers, but the thing I like about Energous is you've done an amazing job on the antenna design, and so basically the coverage and the orientation of the tags is less and less significant. So it's kind of makes the deployments a lot easier, and you have excellent range, a lot of power, and but not too much power. So we can start to establish these zones in the stores and figure out where the inventory is in real time. And I think that's clear. It's it's becoming more and more important as retailers are figuring out how to be successful post COVID. It's about letting customers buy any way they want. They want to buy online and pick up in store. They want to buy online and have the store essentially being a distribution center for deliveries into the home. Then basically real time inventory becomes essential in that world. If you're going to have staff that are really making this a pleasant shopping experience and storytelling and relationship building, they can't be running around trying to find stuff. They need to be focusing on the customer, and your infrastructure and the Wiliot tags allow them to do that. So I think that's it's a really valuable combination. One of the things that I think you guys are also very good at is certification, and maybe it comes from your heritage of you've been dealing with, the highest bar in terms of certification, and
Definitely. I mean, I was going to mention that. I'm glad you brought it up. I think what's important here is the fact that the product that we're working with it right now, has been certified not just in the U.S. and Canada, but we have certification in India, we have certification in the European Union, and believe it or not, China, which is extremely difficult to get, as well as Australia and New Zealand now. So we have really covered more than, I would say, 90% of the world's market right now. And we're going to be working on couple of Asian countries next. And with that, we should pretty much have enough information to cover the whole world, which you will not be able to get with any other vendor. And we work really well together on that. Yes.
let's just talk a bit about what's going on in Australia, because we're doing a whole bunch of projects. We don't always get to talk about them publicly, but you guys have been making some noise about deployments there. Do you want to just say a few words on
Definitely. I
that?
mean, as you know, both of us have been working with Flagship, which is a local company in Australia. And sometimes we do a lot of technical work and we forget what we're doing. But as I was telling you, I believe yesterday, is from my perspective, we can really claim that the Australians are ahead of everyone in the world because they're the first ones to publicly announce, in my opinion, an active power network that has basically powered multiple retail stores with thousands of RF tags. And I don't know of any other place that has effectively claimed that so far.
Yeah, we have the Flagship guys on the show, and they're providing the systems that allow the store of the future to be the software systems for the store of the
Exactly.
future
So
to
we
be
announced what
managed.
two retail stores. I think one of them is identified by name, and the second one is not really public yet. And I guess it's called Academy Brand, which is a retail company in Australia that has multiple, I guess, sites, and they're looking at the technology, and so far so good, which makes us very happy.
Likewise, likewise. So, Caesar, this is the second segment of the show where we get into a little bit more about you. And you've got an amazing job. You're CEO of Energous, which is a really cool company. I'd love to know a bit about your career and how, you've also worked for some other very cool companies. So can you did you know what you wanted to do when you were in college? Is this what you kind of envisaged for yourself?
I knew what I wanted to do when I was 9 years old, believe it or not.
That's amazing.
I was trying
That's
to figure
very
out.
unusual. Very
Yeah, I
unusual.
was trying to figure out if I wanted to be a doctor, medical doctor, because my mother wanted me to be a doctor, or whether I
Okay.
should be an engineer because my father was an engineer.
Uh-huh.
And I decided to go for engineering. So that's pretty much what it is. And I wanted to be a high voltage power engineer, believe it or not. So I am an electrical engineer, but I wanted to send and design transmission lines and substations and things like that, which is not what I'm doing right now.
Oh, I know. You're dealing with power that's not going to kill someone. That's for sure.
Exactly. Somehow I ended up doing power, but not that high voltage power that I knew of, 10,000 volts or 20,000 volts or even more than that.
And so that
Great.
got
Yeah.
you into university, and what did you study in university?
Yeah. So I attended Polytechnic Institute of New York, which is today the engineering school at NYU. also known as Brooklyn Poly in New York, second oldest electrical engineering school in the country, right after
Huh.
MIT. So very few people know that. So I went to New York. I mean, I wanted to live there and go to school there. So pretty much ended up.
Where did you grow up?
I,
Just
I
out of
grew up
interest.
in Lima, Peru, uh,
Okay.
and my parents sent me there to some relatives so that I could attend college. And the whole idea was that I would be in the U.S., get educated, and go back and work with my father, which
And
never
so, what
happened.
was your life like in Peru? Sorry to interrupt you, but what was your life like in Peru? Your dad was an engineer, so you were in a middle class family, I guess.
Yeah, we come from an interesting line of engineers, and we ended up basically in Peru through my grandfather, who was an American engineer also. And I ended up living there for a couple of generations and going back and forth between Peru and the US. And it was my turn to come back. And the whole idea was to be educated in the US and go back and again work with my dad. But that never happened. I decided to just continue here and got interested in electronics, believe it or not. Back in the 80s, early 80s, doing VLSI was really uncommon, and it was a new technology, and you could not find too many books in VLSI or electronics, and very few of the professors actually knew about it. So I got interested in electronics, and that was my passion. So I ended up in school at Brooklyn Poly helping my professor opening up the first VLSI lab for the school, that is. And it was probably one of the first VLSI labs in the country.
And what did the lab do?
We actually had a deal with Mentor Graphics. Believe it or not, Mentor Graphics was back there with tools, and we were able to get some donations from Mentor Graphics, by which we had what's called Apollo DN 3000 computers, which were the predecessors to Sun workstations.
Right, right.
So we
That
got the
was
software, and my job was to install. Then we came up with a set of projects that allow people to design VLSI circuitry and pretty much put systems and chips together. So that was the idea because the school didn't have a VLSI program by itself. I mean, I actually took the first course in VLSI with this professor that eventually took me and to the into the Bell system. So that's pretty much the story there.
amazing. So, how did you get from the lab into industry?
So the way it worked is I was offered a 12-week job at Bellcore, Bell Communications Research, which was the what's called back then the Ma Bell's research lab. AT&T Bell Labs ended up being the long distance labs. So I worked for the Ma Bells for 12 weeks, and they gave me a project on video transmission over fiber optics. And at the time, my job was to design effectively a transmitter that will allow you to send what's called broadband ISDN data and video over fiber optics. And I only had 12 weeks, and I was told that because it was 12 weeks, I didn't have to finish it. So I just worked hard and finished it, and that got me my job.
That's fantastic.
Yeah.
You know, some people, I mean, to me, Bell Labs is like the most amazing institution, but some people may not know about it. Can you just tell us who were
Definitely.
Bell Labs? What are the technologies that came out of Bell Labs?
Oh, there's so many technologies. So Bell Labs is the old research labs that was pretty much established by Alexander Graham Bell, who is effectively the inventor of the phone. And that was his company, and it was a worldwide company that pretty much owned all the telephone network as well as all the research around the world. And then I happened to be at the time one of the last young engineers that actually joined that leftover that had gone through 120 years. And I was kind of uh, I would say, lucky to actually be there because I saw how it was, but I also saw how it was really taken apart. When I go back and say what it was, I mean, as a young engineer, I could do anything I really wanted to do within, of course, the parameters of what the lab wanted us to do, and there was no restrictions on engineering knowledge, whether you wanted to do hardware, software systems, semiconductors. You did what you had to do to deliver.
But this became the research arm of AT&T, right? And they
Yeah,
did
so
like
the Bell
pioneering
system.
work on the transistor and fiber optics, and they invented Unix, that then became basically the
Yes,
basis of all of the operating system that's running on your phone.
that's
It's
correct. So the transistor was invented in the Bell system. The telephone switching network was invented in the Bell system. The cellular phone network was invented in the Bell system. The concept of using queuing theory for networking was used day and night by the Bell system. The fiber optic transmission systems and the rings and the Sony rings and was invented there. DSL was invented by the Bell system. So a number of technologies because we had pretty much 2% of the revenue of the company went into research. Only 2%, and we did all that. Now imagine today you don't even put 2% and we cannot do much anymore. So I was lucky enough to end up in a place that had enough money to do whatever that was needed to do without any limitations, which you don't do anymore in the U.S. and universities don't even cannot even afford to do that anywhere. So I was happy and fortunate to see it, and I also saw it going away when I was told that it was the time to do software, and the company was going away from hardware. Yeah.
hmm. So what happened after Bell? How did you end up leaving?
So I worked in the Bell system for about 8 years, and I worked on broadband ISDN, so transmission of multimedia over fiber optics, all the way from 155 megabits per second, which is nothing now. But back then we couldn't even build a chip that would run at 40 megahertz or 40 megabits per second. So we did 155, and I worked up to 2.5 gigabits per second. And then I said to myself, I had enough of this. I have to do something else. So an old friend of mine, who was my boss by the name of Steve Weinstein, who is considered one of the main inventors of OFDM, and you know what OFDM, or orthogonal frequency multiplexing, division multiplexing, which is pretty much on in communication networks, including Wi-Fi, had moved to a research lab in Princeton, New Jersey, by the name of NEC Research. And I called him up and I told him I was bored and I wanted to do something different. And he offered me to join NEC and work in wireless. And I had never done wireless before, and they wanted to build a multimedia based wireless system. So that's how I got involved in wireless and started that in 95. And that eventually ended up interesting me in moving into California because we used to do research for the sake of being great engineers.
Hmm.
But back east, a lot of the jobs were going away and they were coming to the West Coast. So I made the right decision at the right time. So around 1999, I moved to the West Coast, worked a little bit on DSL. I was in a startup doing DSL. I worked a little bit on CPUs with Arc International. And then I ended up at Broadcom running the Wi-Fi team for a number of years. We did some of the first single chip devices, 54G Wi-Fi. Then we did some of the first 2x2 MIMO. And around 2006 or so, I moved to Marvell Semiconductors, where I was for 8 years running pretty much all of the connectivity, Wi-Fi, Bluetooth, and so on. So by then I was a very strong wireless uh, engineer, let's put it that way.
Hmm.
But then somehow, about 8 years ago or so, after I once more I got bored. I get bored of things, as you can tell now. I get bored of doing wireless communications because it's just repetitive, and
Hmm.
a lot of people might not agree with me, but I don't see Wi-Fi making any progress since MIMO. It's just been
Hmm.
extending the bandwidth, extending the rate, and that's easy to do. I mean, MIMO was a fundamental change on modulation. So I wanted to do
Hmm.
something different, and I got a phone call from Energous where they actually wanted to do wireless power. They wanted to do wireless RF energy. And then I said to myself, well, I wanted to be a power engineer. I know wireless. Why not? So let's see what we can do. So the idea was to merge my research background with my engineering background and then see if we could do something like that. So that's pretty much what happened. Then I joined Energous, run engineering. I was the COO for about 3 years, and now I'm the CEO for almost a year now. So that pretty much is it.
Okay, so if you want to be CEO of a company like Energous, it's as simple as that. That's all you have to do.
That's a fast
That's quite
path.
a journey. That's amazing. So, how did your dad feel about you not going back to Peru? That must have been tough.
It was tough, but at the same time, it was the right decision. At the time, Peru was going through a lot of, I would say, guerrilla problems, and they had
Hmm.
destroyed pretty much the country. So it did not
Mm.
make sense for me to go back. So his feedback to me was, stay back home where Grandpa is from, and
All
don't
right.
come back.
Very, very
But that's what
interesting.
happened. Yeah.
Well, that was fascinating. On to the last question of the show, which is about music. And I don't know how big a deal music is for you, but did you manage to think of three songs that are your
Yeah,
favorites?
yeah. So I like a lot of songs. I mean, it's not just one song, but what I ended up with is that there are certain stages in your life that make a big difference. And for
Hmm.
me, since you asked me the right question, which is what did you do after you left Peru? I think that stage from where I left Peru and I worked in the East Coast in the US is what really sets who I am and what I know and pretty much my behavior and what I do in life. So what I decided to do is come up with three songs that effectively remind me of the 1980s, right? In a way.
I love this already. I love it. Okay.
Yeah. So the first song that I came up with was a matter of fact, which is Billy Joel. And Billy Joel
Very
was
good.
very popular back then. He's one of the most famous musicians out there, and everyone knows of him. So I think a matter of trust is important from from the fact that if I hear this song, I still remember when I was 17, 18, 19 years old. And that's when
Marvelous.
again my whole personality started really being focused and I really went into that engineering direction. The second song, which really brings me back big memories, has to be basically Frank Sinatra, New York, New York. I mean, I was in the middle of New York. I know a lot of people don't like New York, but a lot of people nowadays love New York. So
I love it.
New York is like the national anthem of New York City, and I think that song is very important because if you can make it there, you can make it anywhere, and that is true. I mean, I made it there, and I'm trying to make it everywhere. So that's the
Excellent.
second thing. So
Uh,
1980s. And I think the third one is more about life. It's more about what you want to do and what you end up doing in life. And I would say Frank Sinatra My Way is extremely important because at the end, it's all about who you were, what you did, and certain times you had to do it your way. So I think those three are the important ones that again, they're not the only ones, but it really focuses on very, very focused and very fundamental things in my life.
Yeah, those are great choices. And My Way is such a iconic song. And I was just trying to think. I don't think we've ever had that. I think you're like approximately guest 160 something. And I think that's the first time it came up. But it's a great choice, and I enjoyed it. Well, Caesar, you've been very generous. Thanks so much for talking with us. I really, really enjoyed it.
Likewise, and thank you for inviting me.
Thanks for watching this clip from the Mr. Beacon podcast here on YouTube. You can listen to this episode on iTunes, Spotify, or wherever you get your podcasts. If you enjoyed it, please like and share this video, and be sure to subscribe for more weekly videos. For more information about Wiliot and IoT Pixels, head on over to wiliot.com.